In chemistry, we use chemical equations to represent chemical reactions. The balancing of a chemical equation is a very important skill for every student of chemistry and even for practicing chemists. The balancing of chemical equations itself is a consequence of the law of conservation of mass and also the law of conservation of atoms. What do we mean? We mean that if our input is, for example, 2 kilograms, then the output should also be 2 kilograms. So input and output mass should be the same if it is a chemical reaction. So this is our input. Input mass should be equal to output mass. So the input is equal to the output. This is the law of conservation of mass. Then there is also the law of conservation of atoms during a chemical reaction. What we mean here is that if we have two atoms, let's say in the input we have two atoms of carbon, at the end of this chemical reaction, we should also find two atoms of carbon atoms. There should be two atoms. See, two carbon atoms. During a chemical reaction, mass is conserved. During a chemical reaction, atoms are conserved. These are the two laws that form that give us the rationale to balance all the chemical equations that we can write. I'm going to explain in this video the various tricks, techniques, and approaches that you can use when you are balancing different chemical equations. I'm going to start with balancing combustion equations. They are very common, the combustion reactions. Let me just say combustion reactions. We usually find these kind of reactions in organic chemistry. Combustion reactions. If we have a fuel like let's say propane, this is the fuel, and we burn this. If we burn our propane, we're going to have the products of combustion. Propane is we call these hydrocarbons. It's a hydrocarbon. If we burn hydrocarbons, the products of the combustion of hydrocarbons is carbon dioxide and water. Carbon dioxide plus water. We know about this. So I'm going to write the reaction, the chemical equation for this reaction, and then balance it. That is what I'm going to do here. So it is propane, which is C3H8 plus O2, the oxygen. Whenever we say we're burning or there's a combustion reaction, it means we are reacting a fuel with oxygen, or we're reacting a material with oxygen. What we get, because this is a hydrocarbon, and if it is complete combustion, we get carbon dioxide plus water. So the first thing that you have to do is the ability to write the chemical equation itself. If you can write the chemical equation, that is one part of it. That is a very important skill that you need. If you are a student of chemistry, or even if you're a chemist, you need to know how to write chemical equations. What is important here is to make sure that all these, they are written in their correct formula, chemical formula. So H2O for water, O2 for oxygen, because oxygen in nature it is a diatomic molecule, O2. Then we have carbon dioxide, CO2, and propane itself, it is C3H8. If you write every compound or every element involved in the reaction in the correct chemical formula, then you need to balance the equation now. So this is this is a reaction, but it's not balanced. Let us go to balancing the equation. I have to mention here what you need to do when you're balancing. You are going, let me say, the don'ts. The important don't here, do not alter or change formulae. CO2 should remain CO2. H2O should remain H2O. In other words, you're not going to change these subscripts or add subscripts here. No, not at all. The formula are going to remain what they are. Do not change the formula. What you should do here, use or maybe change coefficients. Change the coefficients. These coefficients are the numbers that are here. Let me use let me say A here, and then we have a B here. I don't want to use a C here. Let me use an X and a Y. This is all what we do. A, B, X, and Y are constants. They're just ordinary numbers. This is what we have to change. So we add or we alter. We can do that when it comes to the coefficients, but not the subscripts, not the formula. They remain what they are. This is what you do when you're balancing chemical equations. Now, let me go now to balance this reaction and the tips that you need to use. Let me go here to the most important tip. Balance the element last. Balance elements last. For example, what we call an element is simply a substance that you've got this same type of atom. That's an element. E.g., here, if we have something like O2, or we have N2, H2, etc. These are elements, and when we balance our chemical equations, we balance them at the last. If we do that, you're going to see that balancing the chemical equation becomes very easy. But that is if you have an element as part of the chemical equation, you balance it at the end. Another tip that I want to give you is you can use decimals or fractions. It doesn't mean when you're balancing a chemical equation, these coefficients that we're talking about should only be whole numbers. They can be fractions or decimals. And if you use the decimals and fractions, sometimes it actually makes it very easy to balance that chemical equation. At times you may have to, if things go a bit difficult, you may use, you may have to solve simultaneous equations. You may have to do this sometimes. There are times when, for you to deduce one of the, maybe there is only one missing coefficient. For you to deduce it, you may just have to form some simultaneous equations and then solve them simultaneously. You may get what you're missing. I want to emphasize that this is all about practice. See? Practice. Balancing chemical equations is more of an art. The more you do it, the easier it becomes for you. So try to do is practice this balancing of chemical equations. The moment you do it many times, it becomes very easy for you. So it is a skill that you can develop easily through practice. That is all, because sometimes you just balance a chemical equation, not because you were using all these tips just because you know it from experience. So let us go back to balancing our equation. We said we have C3H8 plus O2, which is oxygen, and from here we got carbon dioxide plus water H2O. Let us start with carbon. We have 3 carbon atoms on the left hand side. So I'm going to start with carbon, LHS, and the right hand side we have 3 here, but to the right hand side we have 1. To have 3, we have to multiply this by 3. We are changing the coefficient. We're not changing the chemical formula for carbon dioxide. We can put a 3 there. Then if we do that, 3, it's balanced. Now carbon is balanced, left hand side and right hand side. Then we go to hydrogen. To the left hand side, we have 8. H. We have 8 on the left hand side, and to the right hand side we have 2. We have to multiply this by 4, so multiply by 4 so that we have 8. I multiply here by a 4, changing the coefficient. If we do that, our hydrogen is balanced. Then we are going to balance oxygen lastly, because it is an element. This is an element. Oxygen here is an element. That is why we are balancing it lastly. Let us go now. We start on the side with the most or with more numbers of atoms, which is the right hand side in this case. So we have RHS, right hand side. We have oxygens. We have 3 by 2, which is 6 plus 4, so we have 10. And on the left hand side we have 2. To get 10, we have to multiply it by 5. Then we can put a 5 here. If we do this, our equation is balanced. Everything is balanced. So we have balanced our chemical reaction. It was quite straightforward because we had an element involved in this chemical reaction. Therefore, when we are balancing it, we just balance everything else and then we go to the element and balance it last. All right, let me do another example. A common reaction, nitrogen plus hydrogen, for us to get NH3, which is ammonia. So this is the reaction for the Haber process. We know that we take nitrogen, we react with the hydrogen, and we get ammonia. We know about this. Now the question is how do we balance this reaction? All right, let us start with the right hand side. We have 1 nitrogen here, and yet we have 2 nitrogens that side. So we can balance a nitrogen by just multiplying it by 2. So we multiply this by 2, and then we now go to balance our hydrogen. 2 times 3 here on the right hand side, we got RHS for hydrogen. We now have got 6 of them, and yet on the left hand side we have 2. We have to multiply this by 3 so that they become 6. So we put a 3 here. Once we do that, we have a balanced chemical equation for the Haber process. This is how we balance it. Another common reaction that you know is for the contact process. we have this during the when you are manufacturing sulfuric acid, we have SO2, sulfur dioxide. We are reacting it with oxygen to form sulfur trioxide. Now we need to balance this reaction. Let us start by balancing oxygen. On the left hand side we have 2. On the left hand side we have 1, 2, we have 4 LHS. We got 4, and this is for oxygen. On the right hand side we have 3. Then if we go to sulfur, LHS, we got 1, and RHS, we also have 1. So we want to find a way of balancing our oxygens. Let us balance it on the left hand side. On the left hand side we have 4, so we are fine there. Let us balance on the right hand side. If we multiply 3 by 4 over 3, if we have 4 over 3, we multiply this by 3, we get a 4. So we can balance here by multiplying this by 4 over 3. If we do this, we balance our oxygen, but then we upset the number of sulfur atoms. See, once we try to balance the oxygen, we upset the number of oxygen atoms. This is why this is a case where you can balance this using decimals. So for you to balance such an equation, you have to rely on decimals. So let me rub this and show you how you approach this kind of equation. Okay, I'm going to rub all of this. Now, the easy way to balance this equation, we are going to rely on decimals or on fractions. We see that our sulfur is balanced. The sulfur here and here, it's 1, 1, that's okay. Our oxygen, to the right hand side we have 3, to the left hand side we have 4. But we can make them 3 by multiplying by half here. If we multiply by half, it is now balanced because we have sulfur 1 on LHS. We also have 1 on right hand side. When it comes to oxygen, we have 3 on the right hand side. We also have got 3 on the right hand side. Left hand side 3, right hand side 3. So it is now balanced. It's a balanced chemical reaction. I want to rewrite this reaction again. So it is now SO2 plus half O2, we get SO3. It is balanced. If you do not want to have fractions as part of your coefficients, you don't want to have fractions or decimal coefficients, you can just multiply. In our case, we just multiply by this denominator here. So multiply by 2. Multiply by 2 throughout. If we multiply by 2 throughout, we're going to have now 2 SO2 plus O2 to get us 2 SO3. This is the tip where I am using a decimal or a fraction here. I used the fraction and it made everything now easy. If I want to remove the fraction, I just multiply by the denominator of that fraction throughout, and I have something here which is still balanced. So this is a balanced chemical equation of the conduct process or the production of sulfuric acid. This is the chemical reaction. I have here, look, on the left hand side, I have 2 sulfur, and I have 2 sulfur atoms on the right hand side. On the left hand side, I have 6 oxygen atoms, and on the right hand side, I also got 6 oxygen atoms. It is balanced. This is how you balance this equation. I want to do some other examples that involve, let me say, acid-base reactions. I have an acid here reacting with a base. Let me say I have sodium hydroxide, which is a base, and I'm reacting it with an acid, sulfuric acid for that matter, H2SO4. If I react an acid and a base, I get a salt and water. The salt that we get here is sodium sulfate, Na2SO4 plus water, H2O. This is what I get. If I check this reaction, it is not balanced. It is not balanced at all. Sodium atoms, we have 1 here, we have 2 here. Hydrogens, we have 2. We have 2 there, they are balanced. Sulfur, we have 1 here and 1 there, they are balanced. Oxygen, we have 5 on the left hand side. On the right hand side, we have 5. On the left hand side, we also have 5. But the sodium ones are not balanced. We have to balance this reaction. Let us start by balancing the sodiums, which we have 2. We have 2 on the right hand side. We have to put a 2 here. But once we do that, we upset the number of hydrogen atoms. We upset the number of hydrogen atoms. We now have got 4 on the left hand side, yet on the right hand side we have 2. Let us multiply them by 2 also. We put a 2 here. Let us check. Sodium is 2, so Na got 2, 2, balanced. Let us go to oxygen. We got 6 on the left hand side, and also 6 on the right hand side. It is balanced. Then we go to sulfur. We got 1 left hand side and 1 right hand side. It is balanced. Then we go to hydrogen. Right hand side we got 4, and left hand side we have 4. Balanced. So all we did here, we just tried to we started by balancing sodium, and then we went on to balance our hydrogen, and everything just fell into place. This is why I say this thing is an art. It is an art. From experience or from practice, you just get things right quite fast. You just